Hello everyone and welcome back. This lecture will continue our discussion on k-means clustering. Specifically, we'll do a k-means cluster analysis for 1 to 10 clusters. Okay. Let's start by splitting our dataset into training and testing datasets. And for that, we'll use the train test split method. We have already imported that. And then we'll pass our cluster A standardized clustering variables. We'll pass a test size of 0.3, 30%. And then let's pass a random state of, let's say 222. And if you want to get the same result as me, you can pass 222 for your random state. And we'll save this in a couple of variables. I'll name them cluster train and cluster test. Okay. Here we're not doing x train, x test, y train, and y test as before. We're not that much interested in all of those. We're simply interested in making clusters, right? That's our goal. That's why I'm dividing our dataset into training and then testing datasets only. And if you check the shape of this cluster train and cluster test dataset, you will see that it's two-dimensional. Okay, so let me show you that. Let's print out the cluster train dot shape and cluster test dot shape. Oh, I'm missing an alphabet here. Let me run it again. So here it's two-dimensional. For our cluster train, it's 3,200 rows by 11 columns. And for our testing, it's 30% of 4,600. I just wanted to divide our dataset into training and then testing sets. So when we build our cluster, I will be using the cluster train dataset for building our cluster. So we'll be doing a cluster analysis for 1 to 10 clusters. So I'll start by defining a variable called clusters, and it will have values from 1 to 10, so we can use the range method. And then once we create that object, we can specify the number of clusters that we want to test from all those range values from 0 to 10. Okay, and then for that we'll use a for loop, and we can say something like for k in our cluster object, and then we can have some more codes. Okay, let me type the code and explain as we go by. I think that will make more sense. Okay, I'll start by defining the clusters variable, and we'll say range 1 to 11 so that we can have 10 clusters. Let's also define another variable. I'll just call it mean distance, and I'll create an empty list, and later we'll append to that empty list. So what I will do is we can say for k in our clusters. So for k in clusters, we'll build our model, our k-means model, and then we'll pass number of clusters. We'll set it to k. So when k is 1, the number of clusters will be 1. When k is 2, and so on. So for k in clusters. And let's save our model in a variable called model. And then we'll take our model and then train it with our training dataset by calling the fit method, and we'll pass the variable that we created, cluster, the training dataset that we created, cluster train. And then we'll use a method known as cdist, or before we use that, let's import cdist from SciPy. So what I will do is from SciPy that spatial that distance, let's import cdist. It's used to calculate what is known as the Euclidean distance. I will talk more about that in a few minutes. Okay, let's apply the cdist method, and then it takes our data points, our centroids, and then Euclidean, which is the method. So let's pass those. For our dataset, we'll use the cluster train dataset, and then for the centroids, to calculate the centroids, there is a method known as cluster centers. So we can call that method on our model. So cluster underscore centers, that's the method name, and underscore. You can read more about this on the scikit-learn documentation. And the third attribute this method takes is Euclidean, which is the method that we'll use. Okay, and then what we'll do next is take our mean distance empty list, and we will append the result to it. So we'll call the append method, and we'll be appending this, but we're not just appending the result of this cdist method. We'll take the minimum of those errors. So for that, we'll pass another method known as minimum. NumPy has a method known as minimum. So we'll grab the minimum of those, and then we'll add each of that. Let me go to a new line. And since we are calculating mean, here we have mean distance. Since we are calculating mean, we'll divide our result by number of our cluster train dataset, which is 3220. So let's divide it by our cluster train, cluster underscore train that shape, and then we'll pass index 0. So this cluster train that shape is simply means the number of data points or rows, which is 3220. Okay, now let's break down what we did. We started by creating a variable clusters, and here we have 10 clusters, right? We use the range 1 to 11, that means 1 to 3 all the way to 10, and then we created an empty list known as mean distance, and then we used a for loop and said for k in clusters. So the first k value will be 1 when k is 1. Then we're building a model. K means we are instantiating our model, and then pass the number of clusters. So our k means accepts an attribute known as n underscore clusters for number of clusters. So for each k in clusters, we are building our model, and then we're training our k-means model with our cluster train dataset. And here we have the mean distance. So this mean distance that append calculates the average of the sum of the distances between our observation in the cluster centroids. So this formula first calculates the distance between each observation and the cluster centroids, and then we use this cdist function or method to calculate the distance. And this cdist method accepts 3 parameters: your data points, in this case cluster train, you have number of centroids, and this Euclidean. So this Euclidean tells Python to use cdist to calculate the distance between each observation in our cluster train dataset in the cluster centroids using Euclidean distance. And once we calculate that distance, we use NumPy's minimum function to determine the smallest or the minimum difference for each observation among our cluster centroids. Okay, and this axis is equal to 1. It just means that the minimum should be determined by examining the distance between our observations and each centroid. And we take the smallest distance as the value of our minimum, and then we use the sum function to sum the minimum distances across all of our observations. And finally, we divided that result with this cluster train dot shape. This just means the number of observations in our cluster train dataset. So if I print out, just to show you that, if we simply print cluster train dot shape and index 0, we simply get 3220. Since we are calculating the mean, we are dividing it by the number of our observations in our cluster train dataset. Okay, now that we have the average distance calculated for each of our 1 to 10 clusters, we can plot the elbow plot or curve. We can plot the elbow curve by using matplotlib. Okay, and that's what we'll do in the next lecture. Okay, it's important to understand what we did here. Again, just to summarize, once we created our clusters, we used for loops to create a model for each of our clusters, for each of our cluster value k, and this mean distance calculates the average of the sum of the distances between each of the observations in our cluster centroids. So we have a centroid, and then we calculate the distance from each observation up to the centroid, and it does that for all of our data points. Okay, so this first calculates the distance between each observation and our cluster centroids. Then we used this cdist method to calculate that distance. And the word Euclidean here in the cdist attribute, it just tells Python to calculate the distance between each observation in our cluster train dataset in the cluster centroids using Euclidean distance. And you can read more about this Euclidean distance on Wikipedia. Okay, I won't go much into that, but this is a common method now used to calculate the distance between observations and centroids in k-means clustering. I won't go in depth into that, but feel free to read more about this Euclidean distance on Wikipedia. Okay, and once we calculate the distance between each of our training dataset and the centroids, we use NumPy's minimum method or function to determine the minimum difference for each observation among our cluster centroids. And this axis is equal to 1. It means the minimum distance should be determined by examining the distance between the observation and each centroid by taking the smallest distance as our value of the minimum. And finally, we use the sum function to sum the minimum distances across all of our observations. And once we have that, we divide the result by the number of observations in our clustering dataset. Okay, and that's what this line of code means, or that's what it does. And in the next lecture, we'll plot an elbow curve graph for each of these clusters and see how many clusters to use for our k-means clustering model. Thank you, everyone.